brought it through all of our benchmark testing. We've been integrating it into LLMWare in our workflows. And we thought this was actually a pretty notable moment just to talk about some of the progress that have happened in small models over the course of the last 15 months, because we do think that Phi-3 is a marker in the progression of that journey. Hey everybody, welcome to today's video. I don't know if you guys are like me, but if you're deep in AI land, every single day in your social media feed, probably for the last, 12 months or so, it looks something like this. Every day, there's a new announcement, there's a new commentator or a blog post, and in one form or another, it's if you don't get this cool new model, this cool new technology, it's going to change the game, it's going to change the way that we do everything. And it can be a bit overwhelming. I don't know how all of you feel, but to me, every day, it's almost too much to keep up with, of every new model coming out saying this model is going to be a game changer on how this works or on how that works. And so, a new model comes out. We usually take a little bit of time to go through it, to do some testing of it. We do our own fine tuning of that model. We quantize it. We start putting it into some workflows and we start testing it. And a lot of the time, it turns out that the model, while very good and worth all sorts of great things, is probably not deserving of the label of a game changer. However, every now and then you do come across some technology that maybe has that potential to really be something that's transformational. In that context, we actually want to talk about the Phi-3 model from Microsoft. It's a model that they released a couple of weeks ago. We've actually just released our own BLING fine-tuned version of it. We've brought it through all of our benchmark testing. We've been integrating it into LLMWare in our workflows. And we thought this was actually a pretty notable moment just to talk about some of the progress that have happened in small models over the course of the last 15 months, because we do think that Phi-3 is a marker in the progression of that journey. So a little bit of a timeline here. Looking at open source, small base models that have been released in 1 billion to 10 billion. Apologies up front if we've missed anything. To some degree, this was our own stylized experience of it, of all the different models that we've worked with over the course of the last 18 months. But going way back into the 2022 era, really the Eleuther AI, Pythia model, the Neo GPTX, these really were the state-of-the-art, the absolute best of the best open source decoder-based models that you could find and get your hands on. I think a lot of people that were doing work in 2021, 2022, even into 2023, and even in 2024, really a tremendous amount of debt, both to the contributions that were made and as well as the overall quality of the model. We still have two of our best Bling models are on that Pythia base, and most of the base models that have been rolled out over the course of the last year ultimately harken back to a lot of the things that are in Neo GPTX and in Pythia, a lot of the underlying model class code in Hugging Face. But then, starting the recent history, you think about the beginning of 2023, this was the open source response to ChatGPT. I still remember when the Together AI Open Chat Kit came out. It was just awesome. They went out, they gathered a lot of open source Instruct data sets. They had a couple of different partners working with them. But when that hit in Hugging Face, I thought, wow, this is a huge turning point, for open source. Cerebrus, they rolled out their own foundation models. And then, of course, there was sort of the rumored and the semi-release of Meta's Llama 1. That momentum continued through the second quarter of 2023. Falcon, which was released for a while, was absolutely the highest performing model on all the open source LLM leadership boards. Came out in a couple different sizes. There was a 1 billion that we actually used, an awesome model, a 7 billion parameter model, and then the flagship 40 billion parameter model. Together followed up on the Open Chat Kit with their Red Pajama, which was an open source reconstruction of that Llama dataset and rolled out 7 billion parameter and a 3 billion parameter model, both of which we went through some fine tuning with. Mosaic, which is now part of Databricks, rolled out their 7 billion and a 30 billion parameter model. Stable LLM rolled out both their 7 billion parameter model as well as a model that we think has always been one of our favorites, which is the Stable LM 3B 4E1T. We've always found is just a phenomenal model base, to do any kind of fine tuning on, build any kind of RAG application around. Then the third quarter of last year was obviously highlighted, by Llama 2, and then shortly thereafter, the whole world, got introduced to Mistral. Kind of hard to believe that it was less than a year ago. Also, really notably, and again, hard to believe that it was less than a year ago, that's actually when the GGUF was actually rolled out, when GGML progressed to GGUF, And that's actually when the Llama CPP, I think, really started to take shape, along with a lot of the KM quantization techniques being baked into it, but really a very significant impact in thinking about small specialized models. Then in the fourth quarter of last year, there was the E6 billion parameter model, which for a long time was the best performing fact-based RAG question answering model that we had fine-tuned, the Dragon E6B, along with the quantized version of it. There was a fantastic model, probably a little bit better than the hype that it received, which is the DESI LM7B. DESI is now part of NVIDIA. Fantastic model, that DESI LM7B. And then there were these kind of derivatives. There was the Tiny Llama, which had a 1 billion parameter model, a reconstruction of Llama in open source with an Apache 2 license on a 1 billion parameter base, one of our favorite models, actually, to build really small, fast, CPU-oriented inference models on. And then there was the Sheared Llama, which was a research project in Princeton where they did some really creative things around unpacking the Llama model and breaking it up into a 1.3 billion and a 2.7 billion parameter model. Also, two of the favorite models that we've worked with. In the first quarter of 2024, Microsoft rolled out Phi-2, and we're actually marking the date when they actually put an MIT license on it. So it became a fully open sourced offering in January of 2024. Google rolled out Gemma, both 2B and 7B. StableLM actually rolled out a 2 billion parameter model. E rolled out a 9 billion parameter model. There have been secondary versions of many of these models. And then in the second quarter, in the quarter that we're in right now, there's already been a lot that's happened. Facebook rolled out, Meta rolled out the Llama 3 model. And then the model that we're going to talk a little bit about further is Microsoft rolled out Phi-3. So it's been a pretty extraordinary 18 months in the open source community. When you look at all of the IP, and I heard a phrase today about open source, everybody stands on the shoulders of giants, and we're standing and we have the benefit of so many giants that have built and innovated so much IP and contributed it out to the world. And with every incremental model, part of the reason each model keeps getting better is they have the benefit of learning from and working from and building from the foundation that came before it. So pretty extraordinary progress. And I think Phi-3 actually marks something that's pretty important and pretty interesting. And again, the gist behind this video. All right, well, part of what has been going on is you look at all of those models is from 2022 and 2023, there were fairly well-defined model sizes for these small models. There was the 1.3 to 1.4 billion parameter, typically the smallest model. A lot of the base model providers did not even release that model. There was then a model around twice that size, 2.7 to 2.8 billion parameters. And then there was the 7 billion parameter. Now, there was minor variations depending on the model architecture, but for the most part, people sort of borrowed from that architecture and it scaled down in that way to 1.4 and 2.8. Facebook and Meta, they've had a 13 billion parameter model. The original GPT Neo X from Eleuther AI was a 20 billion parameter model, also the size long rumored of ChatGPT. And then there have been various models that have been released in the 30 to 40 billion size and a much, much smaller than that have been released larger than 40 billion. The current state of play and where it's evolved a little bit is, I think, a little bit more experimentation around where in that range is kind of the optimal, the sweet spot where you can maximize both the capability of the model with the size, the speed, especially in the context of quantization. So Tiny Llama, 1 billion to 1.1 billion parameter model, and you notice it. It's a high quality, accurate model that's really fast. Phi-3, super interesting, super interesting. They've built a model architecture that's not in that 2.7 to 2.8 range, but it's actually a little bit bigger. It's really a 4 billion parameter model. E experimenting both with their 6 billion and then 9 billion. And then really interesting, I think, that Llama 3 is coming in at 8 billion. Now, some of this is with some of the new attention mechanisms. You can actually train slightly larger models in the same memory capacity. But then I think also quantization is really a game changer for this. Models that were in that 3 billion-ish range were kind of stuck in no man's land without a quantization strategy. They were in some ways less high performing than a 7 billion parameter, but still a little bit too big to really run comfortably on a CPU. But with quantization, that 3 billion to 4 billion parameter model actually hits a really nice sweet spot because you can run it really well on a CPU, but then if it's high enough quality and accurate enough, you can also always run it on a GPU server as well. All right, I hope that this is going to come through in the video. We're going to put this in a blog as well so that you can really spend some time and see these results. But what you actually see on the screen, so every time that we build a BLING or a Dragon model, we have our own fine-tuning for fact-based question answering. That fine-tuning we build on all of those different base models. And then we run each of them, the fine-tuned version of that model, through the RAG benchmark result test that we've built. It's 200 questions in total. We use the first 100 questions as standard fact-based Q&A over complex business and financial documents. We assign a score between 0 and 100 of the accuracy of the model on those 100 questions. We then have 5 specialized categories with tranches of 20 questions each. For not found classification, can we trick the model successfully by asking it a question that is not in the context passage? We ask Boolean questions, yes or no. We ask kind of some common sense, you call it sort of grade school, math and logic. And then 2 that we score on a more qualitative basis, variety of different complex Q&A, and then some summarization that, again, we score qualitatively on a basis between 1 and 5. And then all of these we actually provide in the model repository with the models. So you can actually take a look and you can see how the selected model you think is going to perform in whatever environment you're looking to bring it in. All right. So with that as a backdrop, let's spend a few minutes looking at these results. And we'll start just looking at Phi-2. You see highlighted, it's in the kind of the middle of the screen versus the Phi-3, which you see at the top. So first thing to note, Phi-2 is an excellent model. When you look at the 2.8 billion parameter models, it's arguably the best performing model at that size. With the BLING stable LLM3B, same size, performing very, very comparably to it. And as I mentioned, the stable LLM3B has been one of our go-to models for a long time. You see both of those models perform just a tick below, just a tiny, tiny tick below the first 7 billion parameter model. So both of those models in this 3 billion-ish parameter range are punching above their weight. They're performing almost as well as models that are twice their size in terms of both accuracy of the score and then in some of these specialized categories as well. That's maybe the first thing to note. BLING2, Phi-2 is an awesome model. Now look all the way up at the top of the list, the Phi-3. So we ran it through. All of these models have gone through substantially similar fine-tunings. There are some differences in the data set. We adjust some of the hyperparameters. In some cases, we find that a model might respond better with slightly different weighting of different elements in our data set. But largely, these models have gone pretty close, apples to apples, on the same type of fine-tuning and then the exact same test. BLING Phi-3, built on the Phi-3 model, broke the test. It got 100 out of 100. And interestingly enough, actually kind of fascinating, the quantized version of the model got 100. So this is actually the scorecard from the quantized version of this model. It scored, at the top in terms of not found percentage, Boolean question answering, and its math performance was pretty close to the top as well. And then the qualitative output in some of the complex Q&A, which are things like table reading and logic and causal questions, was really, really good, as well as the summarization that it provided. So here you have a 3.8 billion parameter model that is actually at the top of this, little leadership board, this private little leadership board, outperforming 7 billion parameter models. Now, again, to sort of draw your eyes to a couple of other sort of logical comparisons here, you can look at Shared Llama all the way at the bottom. Shared Llama is a fantastic small model. In fact, to look at a model for 1.3 billion parameters, it's going to give you, 85% accuracy on basic fact-based question answering is awesome. But look at the Shared Llama 1.3b and then look up at the Shared Llama 2.7b. Doubling in size, you can see a jump in accuracy from around 84.5 to 90. Now let's look at the next jump in comparison. The BLING Red Pajama 3b was a 92. You then scroll up, you look at the Red Pajama 7b was a 96. Again, a few points of increase of accuracy from that 3 billion to the 7 billion jump, just like what we would expect. The Falcon model, the 1B version, got 89, an extremely accurate, 1 billion parameter model. But then you see the Falcon 7B, which was actually built at the same time and trained in the same way as a base model, was about 5 points more accurate. So there's no doubt there's an increase in accuracy, at least of several points, as you migrate from 1 billion to 3 billion to 7 billion. So the fascinating thing to us is that pattern actually has been broken. And some of this is that innovation curve of the open source models, that the models themselves are getting better. Everybody is standing on each other's shoulders. But I think what it also really highlights is that this Phi-3 model is a pretty exceptional model. Now, A few characteristics of it that we think, again, make it kind of a big deal. It is from Microsoft. So now we have a model being launched by one of the largest, if not the largest, tech company in the world with a long history of working with developers. It doesn't seem to be a one-off. I thought Phi-1, maybe even Phi-2 were kind of a one-off. Throw some food out to the open source community, but it looks like they are serious and strategically committed to continue to do this. It is licensed under an MIT license, so it is a permissive open license that enables people to take it without a lot of constraints and do other really interesting things with it. The size of it, of this 3.8 billion parameters, we think is a fascinating middle ground between the 2.8 billion parameters and the 7 billion parameter models. It quantizes very well. We've had excellent results quantizing it and GGUFing the model. It fine-tunes really well, and that's not true of all base models, but we did not have any problems at all with fine-tuning, any issues in training, any issues with hyperparameters. Its accuracy, it performs like a state-of-the-art 7 billion parameter model, but because it's smaller, especially when you quantize it, it runs really nicely on a laptop without GPU. So without getting too into hype, we actually do think this has the potential to be a real game changer of a base foundational small model to build around. It seems like Microsoft has gotten a lot of things right with this underlying model. So what we want to do is we want to do two things. First, we want to show you, now that we've built up a little bit of hype around this, we do want to show you this model. How do you get it and access it inside LLMWare? And then second, we do want to highlight the BLING Phi-3. Now that we've told you it's the model that never gets anything wrong, we want to make sure you can get your hands on it, you can start to break it. So first, let's flip over to the IDE. And what I'm going to look at here is one of the examples. It's in the models repository in the LLMWare GitHub repo, and it's using Microsoft Phi-3. And what this little script does, this is truly just a hello world. In fact, we even borrowed a couple of the examples that were in the Microsoft Phi-3 repository, but it just shows you really simply how easy it is to discover those models, to load and instantiate and cache them locally, and then how to start using them and running inference against them, whether you want the traditional PyTorch version of the model or whether you want to use the GGUF version. When you run this the first time, it is going to take a couple of minutes, especially to load the PyTorch Phi-3. It's a decent size binary that does need to download. It is faster every time. After that, the PyTorch model for inference is a little slow, to be honest, but the GGUF one, both the loading time as well as the inference time, is actually really, really nice. So we would encourage you, go check out this example in the LLMWare repository using Microsoft Phi-3. And then I'm just going to flip over to our Hugging Face repository. Here we are. So this is the landing page for the BLING Phi-3, the GGUF version of the model. You can, of course, pull it down in LLMWare, but we actually wanted to show you, since we told you how good the test results are for this model, you can go to the Hugging Face model repository, and we actually include the test script and the tests. So you can go pull it down, start running this in LLMWare, and you can go run this test for yourself. Pulling down the model, this gives you a full view of how to pull down the BLING Phi-3 GGUF. And the other interesting thing, and this was a topic of an earlier video, we've actually found higher accuracy and better performance setting the temperature to 0 and turning off all of the sampling parameters. So that is the way that we tested this. All right, so I hope that you've enjoyed today's video. Again, there's a blog post that we're going to be doing that shares all the details and all the results of this. As always, check it out on LLMWare. Any questions, of course, come join us on Discord. Thank you, everybody.